Hey everybody, welcome back. Now that I've finally remembered my YouTube password, in this video I'm going to be showing you how we can run full, lightning fast simulations in Blender's shader editor to incredible effect. That's right, while simulation nodes were only added to geometry nodes in Blender 3.6, simulations in the shader editor have been entirely possible since pretty much the first version of the software, and with absolutely no add-ons. I originally developed this setup for creating gas giant textures, and while I intend to make another video diving into those specifically, this has capabilities far beyond that. So let's jump in. So a full simulation in the shader editor. That is a big claim, but I do not make clickbait, so that's what we're gonna do right now. So hopping in, I've got this Blender file here, and the only thing I've really done is I've added this camera, which you can see it's orthographic, scale of 2, and it's just facing down at this plane. And I'm actually going to adjust my render resolution. You can see right now it's 1920, 1080. I'm going to make it square, just like 1024 square. So that way our plane just perfectly fills the field of view of the camera. Now I'm in the Cycles render engine with GPU compute, and I wanted to draw attention to this. I'm going to turn off the noise threshold, turn off denoising, and I'm going to set our samples to 4. That is laughably low, but honestly, we could probably go even lower. I'm also going to turn off light tree, and I'm going to turn on, under performance, persistent data. Our goal here is to have the fastest render times, and you'll see why in a second. Now, with that, I'm going to hop to the shader editor, and you can see I've just got this little material where it's like a checker texture on our plane. And if I hop in here, one of the first tricks that you learn in VFX for materials or anything like that is that we can take this checker texture and we can distort the coordinates that are plugged into it. And so I've got this little setup here to do that. If I just add this in, you can see we get this effect like this. Now, I made a video on basically pushing texture distortion to the max a long while back, but today we're doing a full simulation. And so in a simulation, you take one step forward. And so what I want to do here is, each step of our simulation, I want to do a little bit of texture distortion. So what are we going to do? We're going to do this. And then I am going to hit F12. I'm going to render out this image. Then I'm going to save it. And here I'm going to save it as, I'm just going to save it untitled OpenEXR. And I'm going to save it with DWA compression, because otherwise our file size will be pretty massive. Untitled 1, there we go. Now, I'm going to grab an image texture, and I'm going to grab that image that we just rendered. And if I plug this in here, I'm going to use the UV actually, no, let's use the window coordinates. So it'll automatically be mapped to our camera's kind of view. And now instead of having this checker texture get distorted, I'm going to distort the image that we just rendered out. And so you can see here, we've got like this kind of stepwise recursive effect. And so if I render this out now, F12, image, save as, and I'm going to save this one as untitled 2, EXR, DWA, there we go. And now I bring this in, you can see we're starting to get it's very kind of hidden here. We're getting this gray effect when before all we had was black and white. And that's because as Blender renders this out, it's blurring it a little bit automatically, and that's creating the effect of diffusion. Obviously, if all I came here to tell you was, hey, you can manually bring in these images and stuff, that would suck. That would be a terrible method. It's going to take forever. And so you might be thinking like, oh, he's going to write an add-on to import all these images dynamically, maybe take care of everything. And that's what I did for a while. But we do not need that at all. Turns out Blender fully equipped to handle this for us. So what I'm going to do is we're going to automate each step of this process. If I come to the compositor to automate the file saving, really this is the way you should always save your renders, by the way, is you use the file output node here in the compositor. I'm just going to set this up. Here we go. Remember, OpenEXR, and then DWA. And now I'm going to create a file folder just for our frames, because I want our simulation cache to have like its own folder so that nothing gets screwed up. There we go. And I'll just save all of our images there. There we go. Now if I come back here, you can imagine, okay, on frame 1, we wanted it to just be our checker texture here, right? And we don't need to distort this on frame 1. It's okay to just have it be a normal, undistorted image. So what I'm going to do is, okay, on frame 1, I need it to be this checker texture. And then after that, I need it to be our texture that we're updating. Now, a way that we could automatically set this on frame 1 to be our checker texture is I use this hashtag frame driver with a math node, and I just do less than 1.1. Now it's only white on the first frame. And let's clean up our workspace a bit. There we go. Now I don't like using drivers in Blender actually. They're a bit finicky. I just don't like them. Whatever, maybe a personal taste. Easy solution though that I prefer is the world's simplest geometry nodes effect, where we just store the current frame value as frame. And then we can come over here and grab that attribute. And you can see it works exactly the same. And so I just prefer this. To me, it feels cleaner. There we go. And now I'm just going to plug this into a mixed color node. And we can plug in our checker texture there. So now on frame 1, we get a checker texture. Other times, we're dealing with our actual rastered texture. So how do we automate updating this? Well, instead of a single image, we're going to set this to image sequence. And we're going to give it just any huge amount of frames. There we go. It doesn't matter. Then we're going to set our offset to -1. Then check auto refresh. But see, because this offset is set to -1, you can imagine when I render out an image, like let's say I just do whatever, image 1, this is going to get saved to here with 0001. And so when Blender goes to look for the right texture according to the frame number, this offset, if it's 0, we're on frame 1, it'll look for frame 1. If we're on frame 2, it'll look for frame 2, so on and so forth. Well, if we set the offset to -1, when we're on frame 2, it's going to look for the image that's indexed with frame 1 in that cache, which, since we're dynamically saving out our texture, our render, then it will always find the image we just rendered when it goes to update this texture each frame. And so now I'm just going to update this texture. I'm going to go grab that one dummy image that I rendered, and I have to do image sequence, huge frames. Here we go. Offset -1. If I hit Control F12 to render an animation, you can see, I mean, it looks terrible. Don't worry, we're going to fix that in a minute here. But we are getting a full stepwise simulation entirely using shader nodes. This is 100% shader editor. And we're only working with image textures, so you can see what's our render time. Our render time is 0.09 seconds per frame. That is legitimately almost real-time rendering for this. So one last thing we do have to do. You'll see this is set to Rec 709. That's the default for image textures. We just want to make sure all our images are being saved that way. So I'm going to change that down here. Easier to change it in one area than to remember every time we add a node to change it. So now the question is, why does it look bad? What do we need to fix? I'm going to hand it over to pre-recorded me to answer that. Thanks, me in the chair. Well, if our image texture represents particles of some fluid, then the noise we're using to distort it is the velocity of that fluid at any given point. The issue here is that our velocity field is non-conservative. That is, in some areas it flows into itself, and in others it flows outward. In math, we refer to this as divergence, with positive divergence being outward flow and negative being inward flow. This makes our simulation act like it's infinitely compressible, when in reality, our fluid should have more or less the same pressure everywhere at all times. In a true fluid simulation, we would remove the divergent components from our velocity each frame, but that's not exactly a trivial operation. Fortunately, there's an easy solution which lets us bypass this entirely. It just requires a bit of vector calculus. You see, if we have some potential field, like say a height field, defined by some noise here, we can derive the gradient of that field by calculating the derivative in the x and y directions. This gradient field is basically the opposite of what we want though, since it will be divergent everywhere. But if we just rotate those gradient vectors around the normal vectors of our surface by taking the cross product between those two vectors, we'll get what's known as a curl field. This vector field curls around the high and low points of our height field and will be completely divergence-free. To better understand why this is the case, we can imagine a few particles traversing the gradient field and the curl field. On the gradient field, all of the points flow to a low point on the field, while on the curl field, they eventually return to their starting location, so no energy is flowing in or out of the system. This curl field is what's referred to as curl noise, and it's what we'll want to use to distort our fluid texture. Okay, so back to me in the chair. Thanks, pre-recorded me. So, some of you may have noticed that that's the mathematical solution to our problem, but the eagle-eyed among you noticed that there is no compute the gradient or take the derivative node in Blender. So what we're going to have to do here is basically just believe in ourselves, and we're going to create what's called a three-dimensional matrix exponential, which will let us work inside of a pseudo Fourier space, which will allow us to, I'm just kidding, all we need is a bump node. I kid you not, this is the whole solution. You see the bump node here, if we plug in, say, the factor from our noise here into the height input, the bump node needs to compute the gradient of this input, the height field input, to determine the altered normal vectors. And once it's done that, it just does a few operations to convert from like the gradient info to the altered normals. So all we have to do is undo those later very simple vector math operations to get that raw data. And this is so ludicrously simple. All we need is our texture coordinate node, the vector math node, cross product, and we're going to take the cross product between our new normal and our old normal vectors. And this, I kid you not, we actually get, this is the curl. We actually don't even need to compute the gradient. We just get the curl right out the bat with 3 nodes. Now, I still want the gradient. You'll see why later. So what I'm going to do is do this, and this is the gradient. So we can label these outputs here. And there we go. And oh yeah, one thing I will do is adjust the filter width here. Just by the nature of what we're doing, the traditional bump node filter width isn't quite optimized. You get some sub-pixel artifacting. It's kind of weird. Just set your filter width to something like 1 to 2. Gets rid of the chance of that. It's rare anyway. But yeah, we are, using this for something it's not totally intended for. So I'm just going to call this my curl compute node. There we go. And now, if I plug this in, say I'll plug in the curl here instead of the raw noise. And let's set the scale here. I'll just leave it at 1 for now. And Control F12. Look at that. So that was just 25 frames. But look at that fluid mode. Look how smooth and fluid that is. 0 divergence. And just to showcase this, I'm going to render out 250 frames here. Just to kind of showcase this, I'm going to alter my noise texture a bit. Let's do, what do you think, 3 on the scale maybe? I like to keep the roughness low. I feel like it looks nice. And Control S. I'm going to render this out and then I'll be back. Okay, so while that's rendering out, I wanted to take a moment to talk about this site by Emil Dizwanowski. It's the only website I've found that really uses a trick similar to this, and he had a couple really cool ideas that I've ended up generalizing to use in Blender. His effect was built in Unreal Engine specifically, so if you're a game developer, you might really like this. But I just wanted to shout out his site, to give credit on one hand, but also because there is so much AI-generated SEO optimized slop on the internet these days that I really think stuff like this is just absolute gold. And it's a really good reminder that, when you're looking for cool stuff to try out or solutions to problems, they may not be written in the syntax or written for the software that you're using, but if you're understanding the logic, the solution applies just the same. And it's always important to be thinking about that underlying logic, not just the syntax. And so I wanted to shout out this website. It'll be linked below. Just consider checking it out. Now, back in Blender, our simulation is finished cooking out. And you can see, look at that. Oh, we're on window coordinates. And so actually I'm going to swap to UV. They'll be the same in this case because of how our camera's aligned. But just look how nice that is. That is so smooth. That looks like very organic flow to me. And I mean, this potential field, we can do whatever we want with this. And so I'm going to go attribute. Actually, here, I'll just grab my frame attribute and math node over here. And I'm going to set my noise texture to 4D. Let's divide this by like 400. We don't need this to be too animated, but we can animate this potential field. And so I'm going to keep that part of this whole thing simple for now. And let's render this out again just to showcase it, because why not? Oh, and by the way, you can just watch this in the viewport. I forgot to mention that sometimes it gets weird when I use OBS, and so it might stop on me here, but I mean, this is just, I feel inclined to mention, I'll put it at the end, but there are use cases for this way so far beyond what I'm going to talk about in this video, and even what I'm going to talk about in future videos, that I am legitimately just so surprised I've never seen this in Blender before. And so now in this case, obviously this looks really awesome, but just to add something to our toolkit, you can see when we get to these later parts here, we start off our image black and white. We get to the end, it's a lot more gray. Like there's really not anywhere that's really stark white or completely black. And partly we kind of want that. This is the diffusion effect that we built this whole system for. But we also want to be able to control that. It's nice when things just happen to look good, but it's really nice when things look good because we made them that way. Easy solution here, not the most elegant, but it works, is we can just sharpen our image every frame. Blender's applying a bit of a blur each frame just for anti-aliasing. And so we can just, the opposite of a blur is to sharpen something. And I don't really like Blender's built-in sharpening effect. It's either box or triangle. And so what we're going to do is we're just going to make our own. And this is super easy if you never have. All we have to do is blur our image by like the radius of our sharpening effect. And then we subtract that from the original, like so. And then this will extract just the high frequency detail. And so then what we can do is we can just add this high frequency detail back, and we've got a sharpening effect. Now, I want you to figure out what the problem with this might be. You see, we're taking our image, we're sharpening it, rendering it out, bringing it back in, sharpening it again. So in reality, we're basically sharpening an image over and over and over again. And because of that, we're going to have an exponential increase in the high frequency detail. Because the more high frequency detail we have, the more we're going to end up adding. It'll compound and we get exponential growth. And no matter what, that's just going to go really bad really fast. We're going to get crazy artifacting. And so, not the most elegant solution, but it works plenty fine for me, is we grab a vector math node, and we're going to set this to normalize, set this to length, and we're just going to clamp the intensity of our sharpening effect. We're going to say it can never be more than some certain amount. And so now, all we have to do is plug this in here, and I'm going to say, okay, the maximum amount of sharpening you can do is like 0.01, something real small. We probably will barely notice it in this case just because of the image we're working with. But I figured I'd tell you guys about that just so you have it. And with that added, we pretty much have our whole system working for a flat surface. And, you know, that's awesome, I think at least. We can do a lot of stuff with this, a lot of potential possibilities. But, you know, I mentioned gas giants at the start, and that's probably one of the things you want to do with this if you're here on this channel. And so how do we do that? Well, fortunately for us, it's very, very easy. You see, we're going to take our camera, and instead of having it be orthographic, we're going to create a camera that is basically the opposite. It's panoramic, equirectangular, and we're going to rotate it 90 degrees on the X, 0 on the Y, and minus 90 degrees on the Z axis. Now I'm just going to hide my initial camera and my plane. And I'm going to go ahead and add a sphere. And I'm going to give it a decent amount of geometry. It doesn't need too much, but it can just be nice to have that. And I'm going to generate subdivision surface like 1 level. Now, if I just go apply our material, you can think, okay, our image before was being reprojected using these UV coordinates. Well, reprojecting an image texture can sometimes be awkward, but what's not is an environment texture. And so since our new camera is at the center of a sphere, it is effectively just rendering out an HDRI, a 360 HDRI each frame, which we can reproject outward each frame. And so if I come here, I'll make my width be twice my height, because we're doing equirectangular, so this way our pixels will be square at the equatorial line. There we go. And if I go, and I'll open those same images just for now. Offset of -1, give it a gazillion frames, plug this on in, and all we have to do is swap in the object coordinates, Control F12. Oh, I forgot our little geometry nodes effect. That is important. There we go. Now, Control F12. So here I render about 120 frames. And you can see we're getting a bit of artifacting from our sharpening effect still, so I'm going to turn that off. Here we go. Do-do-do. But I mean, look at that. And so I'm going to set the intensity, let's do like 4, and let's run this guy again. And so I've just rendered out 250 frames. Just look at that go. This might be a bit too quick, but like, I mean, I just love that. And look at our render time. We're still at what, 0.2 seconds, so 5 frames per second for our simulation. For a 2K texture, that's not too bad. And so I'm not going to go into a full deep dive on making gas giants in this video. I just wanted to kind of cover the system, and then I'm going to make another video that's entirely just about sculpting this noise field to give you awesome results that are very gas giant-esque. For right now, though, I mean, sometimes it just takes a bit of working with this to build an intuition. But like if you think about, okay, if I want to add storms like, or cyclones, if I want to add cyclones, I would just add a Voronoi texture to here. And you can see, okay, our fluid is going to curl around all these spots. And so maybe make this a smooth F1, give this like 0 roughness, adjust the smoothness a bit, and then color ramp this. If I flip this, here we go. Now you can see we have what are basically just going to be isolated cyclones. And so you could add this to other noise. Otherwise, I'm going to set this to ease, by the way. Here we go. And just a quick showcase. I'll render a couple frames. This is obviously way too intense. You'd have to scale down the intensity of your noise. But there we go. You can see, okay, we've got clearly just these spinning vortices. Easy thing to add. Now I'm going to scale this, make this like 0.5. And, you know, we outputted this gradient here. And so if, in theory, obviously our simulation isn't perfect and it's Eulerian, and so there's all the issues with that. But if we wanted like our fluid to say not just orbit around these points, but also to maybe like spiral inward or outward, we can just add a bit of this gradient to our curl. Now, obviously, this does break that incompressibility aspect I talked about, but it's artistic license. We're sculpting this to look good at this point. And so, if we want to justify it, we can say it's like different gases being exchanged between different cloud layers, or like being brought up to the surface of a gas giant. Very easy thing to rationalize. Now we'll just render this out again. Control F12 to do that. Oh, like look at these guys. That looks so nice. And yeah, you will get a bit of distortion here with the equirectangular projection, particularly at the poles. There's only so much we can do about that, unfortunately. But you can see it drops off very fast, and even here, it's only noticeable because we have no other distortion going on, and so the blurring effect is applied kind of incorrectly in image space versus world space. So that's what's causing that. But I mean, this looks pretty solid. Like, if you want to add cyclones, boom, cyclones. But yeah, that's an easy way to get these really nice, simple cyclones. Also, the Gabor texture surprisingly does a great job with this. As I said, I'm not going to do a whole gas giant tutorial in this video. That's going to be another one. And so I think I'm going to leave this video here for now, and I'm going to hand it over to pre-recorded Logan for the outro. Thanks, me in the chair. A huge thank you, first of all, to all of my patrons over on Patreon. Y'all are absolutely wonderful, and there's full project files over there for the animations I've shown if you want to get those. There's clearly plenty of room to experiment with this setup and with other projects that utilize recursive rendering, so if any of you have any suggestions, those are always welcome. Feel free to drop them below. And I'll see y'all in the next video.